Prince Gabe the Science Guys.
Prince and Gabe the Science Guys. Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe.
Physics rules.
Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe.
Inertia is a property of matter.
Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe.
Prince Gabe the Science Guys.
Hey Prince, hey Gabe, what are we doing today? Some energy and momentum stuff. Oh yeah? Oh yeah. Is it gonna be cool? Hell yeah. Yeah! There are many different types of energy. Let's take a look at some.
Chemical energy is the energy stored in the bonds of atoms and molecules. In an average car engine, the chemical energy stored in the bonds of the octane in the gasoline is released when the bonds are broken by the heating up of the molecules. Welcome to the world's first kinetic energy race-off! The winner will be decided by whoever has the most mass and velocity. Here in the blue we have Gabe the Destroyer,
into position.
and in the pink we have Prince the Speedster.
On your mark, get set, go!
Okay, looks like Prince is in the lead. He's got the most mass and Oh wait! Gabe has somehow been able to find more mass and more speed, and now he's in the lead. Oh, I think Gabe's about to win the kinetic energy off! Woo! We have a winner!
Gravitational potential energy is the energy stored in an object due to its position from the reference point. As you can see, relative to the ground, I have gravitational energy. Now I don't.
Light energy is the energy transferred through waves and light particles called photons. Check it out. This flashlight outputs light energy which is needed to see us. Light energy. Whoa. Oh, have you seen Prince? No? Okay. Here, follow me. See, sound energy is the energy transferred through waves and vibrations. Check how mad Prince gets when I turn the volume up.
Hey, turn that down! There's too much sound energy going to my ears! We're gonna explode! What? I said turn it down! Turn it up, okay! Oh! These different types of energies can be transformed in many different ways.
As Gabe swings on his swing, his kinetic and gravitational energy are constantly being transformed. At the top, he only has gravitational energy, which quickly transforms into kinetic as he moves to the bottom of his swing, then beginning the process again.
I bet you didn't know that a simple house match has many different energy transformations going on within it. For example, when you strike the match, it's kinetic to thermal energy. Then, that thermal energy ignites the phosphorus on the tip of the match, which starts a chemical reaction. This chemical reaction then releases thermal and light energy. Just like that.
You can make your own experiment at home.
You just need a few simple materials like a ball,
Some string
a place to hang it,
and some space.
First off, you want to attach the ball to the string. Attach the ball to the string. Now that you finally managed to get the ball attached to the string, you need to cut the string to a length proportional to the amount of space you have to work with in the room. After that, attach the other end of the string to the ceiling.
Now that you have it set up, you can test whether all the energy is going to be conserved or not. If you raise it up and release it, and it comes back and hits you in the same spot, energy is conserved. If it doesn't come back and hit you, energy isn't conserved. Let's try it. Whoa, it didn't come back and hit me there. That means not all energy was conserved.
however, if I add additional force, it might just hit Gabe.
Ow! 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 Ow, stop!
No!
Ow! Isn't it cool how hard a baseball player can hit a baseball?
Yeah, the actual distance is actually based on the transfer of momentum.
Actually, momentum is known as the mass in motion.
Well, more technically, it's known as the product of an object's mass and velocity.
Oh.
The law of conservation of momentum states that the momentum at the beginning of a collision is equal to momentum at the end of a collision.
Wait, so are you saying the harder you swing that bat, the faster this ball will go?
Exactly. The faster you swing the bat, the more momentum the bat has, which is then transferred into the ball, sending it further.
Whoa, that's cool.
Momentum. Impulse is a relationship between the force acting on the object, the duration of the force acting on the object, and the change in the object's linear momentum. There are three different situations for impulse. Did you know that one of the impulse situations is when time is constant, but force is increased? Check out this video of Prince pushing a box alone. Now, check out this video of Prince and I pushing the box together. See how when Prince pushed the box alone, he pushed it much slower and it didn't go as far? Whereas when I helped Prince push the box, it went much farther, much faster in the same amount of time? The second impulse situation is when the force acting on the object stays the same, but the time that the force acts on the object increases, increasing the momentum that the object has. Watch this video of a cricket racket hitting a cricket ball. Now watch this video when the duration of the collision is decreased. See how when the duration of the impact is longer, or there's a fall-through motion, the ball goes much further than when there isn't a fall-through motion?
As you can see, during that lightweight championship battle you just witnessed, the gloves acted as a cushion, decreasing the amount of force by increasing the amount of time of the collision. After the boxers took off their gloves, they were able to knock each other out because the cushions weren't there.
In the world of energy momentum, there are three different types of collisions, one of them being elastic. In these collisions, both kinetic energy and momentum are conserved. However, these collisions are basically impossible because they would have to occur without friction or any other type of energy loss. The second type of collision is called inelastic collisions, in which kinetic energy is not conserved but momentum is. Watch as I roll this bowling ball into the bowling pin. You can see how kinetic energy was lost due to friction.
A collision where the momentum is conserved and there is a massive loss of kinetic energy afterwards is called a perfectly inelastic collision. In these collisions, the objects tend to stick together after the collision. Watch this example of a perfectly inelastic collision. A periodic motion when an ideal spring moves around its equilibrium point, aka simple harmonic motion. In this motion, the restoring force of the spring is directly proportional to the displacement of the spring. These vibrations have a constant maximum amplitude, frequency, and period. There are three ways to dampen this motion, one of them being overdamp motion, as seen in many memory foam mattresses. Check it out. The foam comes back slowly to the equilibrium point. Underdamp motion is when an object slowly comes to the equilibrium point while oscillating. Watch as these two springs demonstrate underdamp motion. bet you didn't know that critical damp can be found in the shocks of your very own Ferrari. When pushed down from the equilibrium point, the shocks come right back up without passing the equilibrium point. Check it out.
Prince Gabe the Science Guys. Prince and Gabe the Science Guys. Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe.
Physics rules.
Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe.
Inertia is a property of matter.
Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe, Prince Gabe. Prince Gabe the Science Guys.